Good evening, children. Myself, Srinivas Prabhu. Once again, I welcome to you my YouTube channel, Prabhu's Education Hub. Today's topic: real numbers of class 10. Of class 10. Class 10 standard. Class 10 real numbers. Already most of you know real numbers, isn't it? Still, I will recapitulate from the basics of what we studied under real numbers. So, what are real numbers? Real numbers are denoted by letter R. It's a combination of, that is plus, rational numbers denoted by Q as well as irrational numbers Q bar. What is Q, children? What is Q? Rational number. Rational number. What is Q bar? Irrational number. Irrational number. So, what is real number? Real number is the combination of rational number and irrational number. So, whenever you have doubt, please pause my video again and again and get your doubts clear. And if you have any doubt, please put in the comment box. So just arrange this. We'll go little bit in deep or recapitulate what we have studied. What is real number? Combination of rational and irrational numbers. What is Q denote, children? Rational number. Rational number. So what is rational number? It's a combination of natural number, whole number and integers denoted by Z or I. Set of all these numbers is called rational number. Then what is natural number? Natural numbers are set of counting numbers. Set of counting numbers start from 1, 2, 3, 4 up to infinity. Yes or no, children? Denoted by letter L. What are whole numbers? Whole numbers are set of numbers denoted by letter W. Start from 1, 2, 3, 4 and so on. Goes up to infinity. Then integers denoted by letter Z or I. What are the, children? Minus infinity, minus 3, minus 2, minus 1, 0, 1, 2, goes up to infinity. Set of numbers start from minus infinity to plus infinity. This set of numbers is called what? Integers or denoted by letter I or Z. Understood, children? Yeah. Now arrange this and draw a number line and show that. So that it will help you to remember. What is this, children? Number line consists of numbers from minus infinity to C. It keeps on going from, it extends both sides. Middle number is what? 0 I will take. I'll start 1, 2, 3, 4. So starting number 1, it goes up to infinity, children. Yes or no? What is this set of numbers called? Natural numbers. What is this set of numbers called? Natural numbers. Denoted by letter 1 to infinity. Then before 1 I write 0. What is that? What is this set of numbers called? Whole numbers. Starting from 0 to infinity. Yes or no? Again, there are numbers. Minus 1, minus 2, minus 3 goes up to minus infinity. Understood? What are these set of numbers are called? These set of numbers are called integers denoted by letter I or Z. It goes from minus infinity to plus infinity. Yes or no, children? Integers, negative numbers. What are natural numbers? Numbers start from 1, goes up to infinity. Whole numbers start from 0 and goes up to infinity. Integers start from minus infinity, they go up to plus infinity. They are all called integers. Yes or no, children? Yes. So this is about brief recapitulation of natural numbers. So rational numbers. Now children, see what are natural numbers. Again, numbers it goes from 1, 2, 3 up to infinity. Now whole numbers, one more number is added to this set of numbers. It goes up to infinity. Now what are whole numbers? 0 plus natural numbers. Yes or no? See here. You should get your concept clear. It will come for one more question. What question? I'll tell you. See now. Now, for example, 1. What is 1? It's a natural number? Yes. Is it a whole number? No. 0 doesn't appear in set of natural numbers. What is 1? Natural number as well as whole number. Yes or no? What is 0? Is it a natural number? No. Smallest number in the set of natural numbers is 1. Is it a whole number? Yes. So, what do we mean by that? Natural numbers are whole numbers, but whole numbers are not natural numbers. 0, is it a natural number? No, because it doesn't appear in set of natural numbers. Is 1 a natural number? Yes. Is it a whole number? Yes. It appears in both the sets. So 1 is natural as well as whole number. Natural as well as whole number. Yes or no, children? 0 is whole number. But not a natural number. Yes or no, children? That's it. So same thing you can say for what? Welcome to integers. Denoted by z or I. So return from minus infinity, minus 2, minus 1, 0, 1 to goes up to infinity. This set of numbers. So see here, minus 2. Is it natural number? Minus 2, is it a natural number? No. Is it a whole number? No. Minus 2 is integer. Neither whole number nor natural. Yes or no? Take for example 3. Is it a natural number? Yes. Whole number? Yes. Integer? Yes. Another hint I will give you, children, how to remember. So, among these 3 set of numbers, who is bigger? Integers. Then, whole numbers. Which is the smallest? Natural number. This circle you take, children. What is this? This is set of integers. Denoted by or set. Which is this set? Whole numbers. Denoted by W. What about this? Smallest one, natural number. Yes or no, children? So, natural numbers are whole numbers. Whole numbers are not natural. Small comes under big, but big doesn't come under small. Integers are whole numbers as well as natural numbers. Whole numbers are natural numbers. Natural numbers are not whole numbers. Whole numbers are not integers. and natural numbers are also not integers. Yes or no, children? Yes. Then, in this, you have to remember one theorem, fundamental theorem of arithmetic. Before that, again, we'll recapitulate prime numbers. We all know about prime numbers. Prime numbers. You all know, just let us recapitulate quickly. Then, composite numbers. Composite numbers. What are prime numbers, children? You know numbers which have only two factors. Which are the two factors? The number 1 and itself. Number 1 and itself. Take for example 8. First we'll discuss about one by one analyze this. What are prime numbers? Numbers which have only two factors. Take for example 4. 4. What are the factors of what is prime number? Number which has only two factors. 1 and itself. Itself means same number. Now children, between 1 and 2, any numbers are there? Yes. 2 is there, 3 is there. 1 is the factor of 4? Yes. Smallest factor of any number is 1. Greatest factor of any number is the number itself. Which is the prime, what is 2, children? 2 also is a factor of 4 because 2 divides 4 or 4 appears in 2 stable. 3 is not a factor. Let's not bother. So 4 has how many factors? 1, 2, 3 factors. So 4 is not a prime number. What is prime number? A number which is divisible by 1 and itself, which has only two factors. A number which has only two factors. Which has only two factors. Which are the two factors? That is 1 and itself. No number 1 and itself. Yes or no, children? Now take for example 1. 1 is what? Only 1. There is no number beyond that. We will take it as 1. Now, practically speaking, 1 has how many factors? 1 and itself means same. 1 has only one factor. What is the definition of prime number? Number which is divisible by 1 and it should have two factors. 1 and itself. Here 1 is 1, itself is also 1. Practically speaking, 1 has only one factor. So it's not a prime number. Yes or no, children? Yeah. So now come to the next number. 2. 2 is a prime number. Let us check. 1 and 2. Is there any number between 1 and 2? No. So 2 has how many factors, children? Only two factors. 1 and itself. So it is the prime number. It's a prime number and it is the first number which is prime number, and it is the only even number which is prime number. All other even numbers are not prime numbers. What are they? We will discuss. Just we studied now. 4 has how many factors? 1, itself and 2. It has 3 factors. Any number it has more than 2 factors or 3 or more is not a prime number. What is it? We will discuss. Now, I hope you understood by this. I'll take 2 more examples, then we'll go to next topic. Come to 3 children. 3. 1, 2, we check. 1, I'll write 3. Between 1 and 2, any number is there? 2 is there. So, what are the factors of 3? 1, a number itself. 2, 2 doesn't divide, so 2 is not a factor of 3. So, 3 has how many factors? Only 1 factor. 2 factors. 3 has only 2 factors. 1 and number itself 3. So it's a prime number. Take 5 children. 5, 1 and itself. Between 1 and 3, who is there? 2, 3, 4. 3 is not a factor. 4 is not a factor. 2 is also not a factor. Neither 2, nor 3, nor 4 divide 5. So 1 and 5. 5 is a prime number. Yes or no, children? Yes. Now, the numbers which are not prime numbers, what are they, children? They are called composite numbers. What are they called? Composite numbers. I'll write it here. Composite numbers. What are composite numbers, children? The numbers which has more than two factors. More than two factors. The numbers which are not prime numbers are called composite numbers. Yes or no? Example, we took now 4. 4. It has how many factors? 1, 4. Between 1 and 4, there is 2, there is 3. Now, what are the factors of 4? 1, 2 and 3. It has 3 factors. So, it's a composite number. Take 8. 8. 8 has how many factors? 8 has how many factors? 8 has 4 factors. 1, 2, 3, 4. No need to check what are the factors. How many factors it has got? More than 2. It's a composite number. Yes or no, children? Yes. Then we'll go to co-primes. Co-primes. Another term you should be familiar with. Co-primes. What are co-primes, children? See, for example, we saw 4. 4 is a prime number? No, it's a composite number. Yes or no? Then 2 is a composite number. Yes or no? Yes. Now, do they have any common factor? Yes. What are the factors of 4? 1, 2, 4. What are the factors of 2? 1 and 2. What are common to them? 2. 2. Yes or no? Yeah. Now remove 2 and put 3. Put 3. 4 is a composite number. 3 is a prime number. Yes or no, children? Yes. Now, the 4 is a composite number. 3 is a prime number. When 4 makes a friendship with 3, then it is also prime number. Then they are called co-prime numbers. Co-prime numbers. What are co-prime numbers? Numbers whose highest common factor HCF and LCM we studied in lower class. Yes or no, children? HCF is what? 3, 4. What is the HCF? Do they have any common factor? No. No means 1 is the common factor and its highest common factor should be 1. The highest common factors of two numbers, children, should be 1. Then the numbers are called co-prime numbers. What are co-prime numbers? Numbers whose HCF is 1. Whose HCF is 1. HCF of two numbers 3, 4 is 1. Then they are co-primes. For example, you can say, children, 1, 4. What are they? They are co-primes because their HCF is what? HCF of A, B will be 1. Then they are co-prime numbers. Yes or no, children? Yes. So, we'll go to next topic. What's our next topic? Fundamental theorem of arithmetic. Children, our next topic, very, very important 1 mark question, fundamental theorem of arithmetic. Every composite number can be expressed as product of its primes, and this prime factorization is unique apart from the order in which it occurs. Understood? What is that? Fundamental theorem of arithmetic state. Every composite number can be expressed as a product of its prime factors, and this prime factorization is unique apart from the order in which the factorization occurs. So this is 1 mark question. Please practice pausing the video. Understood, children? Analyze this. This is applicable in our next topic also. Already we discussed, my children. 8 is a composite number. 8 is a composite. It is expressed as a product of its prime factors. 2, 4 are 8. Yes or no? Then again 2 into 2. Return as what, children? 2. Yes or no? Now take another number, 28. 20. What are the factors of 28? 2 into 14. 42 are 28. It's a composite number. Further divide. You can write it as 2 into 7. What are the factors of 28, children? 2 into 7. is nothing but 2 to the power of 2 into 7. Yes or no? 2 square 4, 4 7s are 28. This is the meaning of the theorem, fundamental theorem of arithmetic. Next topic, HCF and LCM of two numbers. HCF. Take two numbers, A comma B. Suppose if you have to find HCF of A comma B, and this will be one more question to the again. Let us assume that A and B are two numbers. For the HCF of A comma B and LCM of A comma B. So before that, let A and B be any two numbers. Any two numbers. Take A and B be any two numbers. Natural numbers. Natural numbers means they take it as positive. Where A comma B belongs to, what is the symbol? How to read this? A comma B belongs to the set of natural numbers. Then HCF of 2 comma A comma B, the two numbers, is equal to what, children? Highest power of each prime, highest power of each common factor, highest power of each prime, highest power of each common factor, highest power of each common factor, highest power of each common factor. Not highest, lowest power of, not highest, lowest power of each common factor, each common factor or each common prime factor, lowest power of each common prime factor in the numbers. For example, children, take the HCF of two numbers. What are the two numbers? 6 and 20. 6 and 20. Example 6 and 20. So what are the factors of 6? 2 3s are 6. Both are prime. Now come to 20. What are the factors of 2? 2 10s are 20. 10 is not a prime number. Again factorize that. What we will get? 2 into 5. So what is this? 2 square into 5. What the highest common factor of A comma B? HCF of 6 comma 20. HCF of 6 comma 20. What is it, children? Lowest power of each common prime factor in the numbers. Yes or no? What the lowest? What the common factor? 2. Yes or no? 2. What the power of 2 here? 1. What the power of 2 here? 2. Lowest power of each common factor. Which is the common factor between 6 and 20? Only 2. Then we take the lowest power of each common factor. Common factor is 2. Here it is 2 square. In 6 it is 2. In 20 it is 2 square. Lowest power of only common factor is 2. And we take the lowest power. What is that? 2. Therefore, HCF of 6 comma 20 is what, children? 2. Easy. Yes or no? Yeah. So, similarly, you can practice this. Easy to remember. Then, HCF of A comma B. What is this HCF of A comma B? Then we will go to HCF. What the HCF of A comma B? Lowest power of each common prime factor in the numbers. Similarly, what the HCM of two numbers? A and B two numbers where A comma B belongs to A. Highest power of highest power. Highest power of each prime factor. There is no comma. Highest power of each prime factor in the numbers. Each prime factors in the numbers. Yes or no, children? Yes. So what do you mean by that? Again, factorize. Factorize. What are the factors of 6? Just now we did now. 2 into 3. What are the factors of 20, children? 2 times are 20. Again 10 can be written as 2 into 5. What is this? 2 into 3. What are the factors of this? 2 square into 5. 2 square into 5. So what is the LCM? What is the LCM? LCM of A comma B. What is the LCM of A comma B? Highest power of each prime factor. Highest power, which is the power of each common factor in the number. 2 is common. What is the highest power? 2. 2 square. 3 is there. There is no 3. Take 3. Then take 5 here. There is no 5 there. This is the LCM, children. 2 square. 4. 4 3s are 12. 12 5s are 16. Therefore, LCM of A comma B is equal to what, children? 4 3s are 12. 12 5s are 16. So these statements, you remember HCF and LCM. What are written? Yes or no, children? Yes. So from this you can derive one more formula, small formula. What is that? We will see. What are A and B, children? A and B are two numbers. A and B are two numbers. Product of A comma B is equal to product of HCF of A comma B and LCM of A comma product of here product of HCF of A comma B and LCM of A comma B. Product of HCF of A comma B, HCF of A comma B and LCM of A comma B. What do you mean by, children? A comma B. Product means what? A into B is equal to HCF of A comma B into LCM of A comma. Yes or no? Yeah. How is that? Now we have taken example, same thing. Take the example of same number 6 and 20. 6 and 20. Example 6 comma 20. Example 6 comma 20. Six comma 20. What the LCM? Just we solve this, no, children. 6 comma 20. So 6 into 20 is equal to what? HCF of 6 comma 20 into LCM of 6 comma 20. What the HCF of 6 comma 20, children? What the HCF of 6 comma 20? What it was? It was 2. What the LCM of 6 comma 20? It was 60. It was 60. The same thing we got here. 20. 26 are 120. 620 are 120. 120 is equal to 120. What do we get? 120 is equal to 120. Yes or no, children? So, hence proof. This is the rule. This is the rule. Again, there will be question based on this formula. If A and B are two numbers, natural numbers, A into B, product of two numbers. Product means it is equal to product of HCF of A comma B into LCM of A comma B, children. Okay. So, this is about HCF and LCM of two numbers. Then we'll just recall about irrational numbers. We have already studied in 9th standard about irrational numbers. So our next topic is what? Revisiting irrational numbers. Revisiting irrational numbers is our next topic. Children, we take a question about what we studied. HCF and LCM of two numbers. Express each of the following as a product of its primes. One more question, children. What the first question? 140. Express 140 as a product of its prime numbers. So 140. What the factors of 140? 270s are. Yes or no? Then again factorize 70. 235s are. Again it goes on in 5 steps. 5 7s are. All are prime numbers. So 140 can be written as what, children? 2 into 5 into 7. What is that? 2 to the power of 2 into 5 into 7. 2 square 5. 5 4s are 27s are 140. This is the answer, children. Understood? So next question. Next question. Three eight two five. 3825. You may wonder, oh, big number. Easy. Why? Because what the 4-digit number? What the unit place? 5. So it's divisible by 5. So 5 ones are 38. So 5 sevens are 38. 5 sevens are 35. 3 remains. 3 into 32. 5 6 are 30. Again 5 5s are 25. 5 5s are 25. 2 carry. 5 6 are 30 plus 2 32. 3 carry. 5 7 are 35 plus 3 38. Yes or no, children? Easy. Again 765. Factor of 5. 5 ones are 5. 2 remains. 5 5s are 25. 1 remains. 153. No, it doesn't go in 5 steps. Now which number? See, children, 153. Add all the digits. What do we get? 1 plus 5 plus 3. Add all 3 digits. 153. Add all 3 digits. What do we get? What do we get? 1 plus 5 plus 3. 5 plus 1, 6 plus 3, 9. 9 is divisible by 3 means 153 is divisible by 3. 3, what's are 15? 5s are 3 ones are. Again 5 plus 1, 6, divisible by 3. See, what is that? Divisibility rule. What you studied in lower class. 3, 1s are 3, 2 remains. 3 7s are 20, 73s are 51. So what are the factors of 3, 8 to 5? 5 into 5 to 3 into 3 into 17. What is that, children? 5 into 5 into 3 into 3 into 7. Not 7, 17. 5 5s are 25, 3s are 75. 75 3s are 225. Into 17 we get 3825. What is that? 5 to the power of 2 into 3 to the power of 2 into 17 is our answer. Yes or no, children? Yes. Yeah. What next, children? What next? Second main question. Find HCF. Find HCF and LCM of following and verify the question and verify that LCM into HCF is equal to product of two numbers. Product of two numbers. Product of two numbers. Two given numbers. Understood, children? This is question number 2 made. In that first part we will take what the pair of numbers he has given. What is given is 26 and 91. 26 and 91. So, we studied now, children. Here we have two numbers. Here A is 26, B is 91. So, factorize them first. What are the factors of 26, 2 and 30? It stops because prime number. It is not divisible by 2. So, what is that? 7 13s are 91. 7 3s are 21. 2 carry. 7 of the 7 plus 2, 9. So, what are the factors of 26? 2 and 13. Factors of 91? 7 into 13. So, what is the HCF? What is the HCF of 26, 91? HCF is what, children? 13. What is the LCM, children? LCM, lowest common multiple. 2 into 13 into 7. So, 2 into 26. What is the HCF of two numbers? Lowest power of each common prime factors appear in that number. Lowest power of each common. Common is only 13 here. Then what is HCF? Highest power of each factor involved in the numbers. What is that? 2 into 7 into 13. Highest power of each common factor appear in that number. Yes or no? Come, we will carry that and see. So what is that? What is that? So HCF. Now 26 into 91. I do it here, children. 26 into 91 is equal to LCM of 26 comma 91 into HCF of 26 comma 91. Yes or no, children? Yes. So what do we write now? We'll write 26 into 91 as it is. What you have to prove? LHS is equal to RHS. What is LCM of 26 comma 91? What is LCM? LCM is 2 into 7 into 13. What the HCF, children? HCF is again 13 into 30. Yes or no? 13 ones are 13 twos are 2 cancel. 13 sevens are 91. So LHS is equal to RHS. Yes or no? Hence proved. Hence verified. Hence verified. Easy or not, children? So again, this is 2 mark question. Previously, what we did? Put star mark. Find, express the following numbers the product of prime factors. This is 2 numbers are given. Prove that LCM and HCF of 2 numbers is equal to product of 2 numbers. This is again 2 mark question, children. Next, revisiting irrational numbers. Revisiting irrational numbers. So, in the beginning I told you what are rational numbers, what are irrational numbers. Combination of both is real numbers. Topic. Lesson is real numbers. What is real number? Real number is the combination of rational and irrational numbers. What is rational number? What is rational number, children? Any number written in the form of P by Q, where P and Q are integers. Yes or no? Any number written in the form of P by Q, where put condition, where P and Q belongs to, what is the symbol? Belongs to set of integers I or Z. And when you say P and Q, they are integers, they can be positive, 0 or negative. Then we put condition and Q is not equals to 0. Why do you put condition Q? Because they are integers now, can be positive, negative, 0. Here, denominator should not be 0. For example, children, 3 by 0, what answer? Infinity, not defined in mathematics. Take example, 0 by 2. 0 can be the numerator. What the answer? 0. 0 belongs to set of whole numbers. But 0 can be the numerator, but 0 cannot be the denominator. Then it becomes infinity. These are the basic things you should know in mathematics, children. That's all now. When we say P and Q are integers. If I say P and Q belongs to natural numbers, then what do we say, children? We don't put condition for Q, because what are P and Q? Mathematics is full of conditions. I told you, I keep telling you, mathematics is full of condition, and you should understand the concept. P and Q are integers, but we put the condition Q should not be 0. If I say P and Q belongs to n set of natural numbers, then I don't put the condition for Q. What are natural numbers? Lowest number is, smallest number is 1. 0 doesn't appear. Yes or no? Example of natural number, 1 by 2, 3 by 4, negative numbers, or 0 will not come here. See, 7 by 9. What are they? They are all fractions. When you say, what is P by Q? Now P by Q is fraction. Yes or no? Suppose if I say P by Q belongs to integers, suddenly the condition arises. I deviated the topic from rational numbers to fraction. And Q is not equal to 0, children. Yes or no? Yes or no? Yes. What are irrational numbers? What are irrational numbers? So this set of rational numbers are denoted by letter Q. What are irrational numbers? Denoted by Q bar. Irrational numbers. Opposite of rational are irrational. What is that? Number which cannot be written in the form of P by Q. You already studied. Not in the form of P by Q. Condition doesn't arise because the number cannot be written in the form of P by Q. What are the children? Root 2, root 3, root 5, root 7, root 8, not root 9, root 10. Why? You might have got the hint, which are not perfect squares. I didn't write root 4. Square root of 4 is 2. Square root of 9 I didn't write because square root of 9 is 3, which is a perfect square. What are irrational numbers? Which are not perfect squares, which cannot be written in the form of P by Q, then which are not non-terminating, non-recurring decimals. Which are irrational numbers? Non-terminating, non-recurring decimals. Rational numbers written in the form of p by q. They are terminating decimals. Terminating decimals. Yes or no? Terminating decimals. Or rational numbers. These are rational, terminating decimals. Or they are also called what? Terminating recurring decimals. Non-terminating recurring. The number is not divisible. Number is not divisible, but it is recurs. 3, 2 doesn't go, put point. Then 3, 6 are 18, 2 remains, 3, 6, 18, 3, 6, 18 keeps on coming up to infinity. 2 by 3 is what? 2 by 3 is rational number. Non-terminating recurring. It does not terminate. Means division process does not end, but the digit keeps on occurring. Such numbers are called rational numbers, which can be written in the form of p by q. But the terminating, non-terminating, recurring decimals or terminating decimals. Many definitions are there. What are irrational numbers? Numbers which cannot be written in the form of p by q, which are examples which are not perfect squares, and they are non-terminating, non-recurring decimals. Non-terminating, recurring decimals are rational numbers. Understood, children? Yeah. This is about irrational numbers. In 9th standard, you have studied about irrational numbers and representation of these irrational numbers on number line. Now, you have to prove that they are irrational numbers. Prove that. Example, prove that root 2 is irrational. A question will come. Understood? A question will come. So how to prove that? We'll learn. So before that, there is a theorem. There is a theorem. What is the theorem, children? Let P be a prime number. Theorem. There is a theorem. Practice this. With the help of this theorem, you will prove that. Let P be a prime number. Let P be a prime number. P be a prime number. That if P divides a square, then P divides A. Again and again we are talking about same thing, children. This is about logic. How to prove this? Logically. There is no any specific rule or any specific formula to prove this. Let P be any prime number, we discussed. Then if P divides A square, then P divides A, where P is a prime number, and A is a what? What is A? A is a positive integer, where A is a positive integer. What is P? P is a prime number. A is a positive integer. Yes or no, children? So just logically how to prove. See, when we write in the form of variables, you don't understand. Take example, then you will understand. Example. Let P be a prime number. Okay? 2. Understood. Let P divides A square. So A square, what do you take? 4 square. Yes or no, children? What does it imply? See, this is the symbol for implies that. A is equal to 4. What is A square, children? A square is 16. 16 is the square of 4. Then A will be 4. If P divides A square, if 2 divides, P is what here? P is what here? Prime number. If P divides 2 square, 16, then doesn't it divide 4, children? Yes. 2 8s are 16, then it divides A. 2 2s are 4. Yes or no? That's the meaning. Oh, now you got the idea. Yes or no? When we take example, then we will remember. Yes or no? Yeah. Now come to the solution. Come to the solution, children. What the solution or proof? You say proof. Yeah. What is the proof? He says, children, that the prime factorization of A be as follows. let the, only based on assumption we prove this, let the prime factorization of A be as follows. What is that? A is equal to P1, P2, P3 up to Pn. Where already we know. What is that? P1, P2, P3 up to Pn are prime numbers. Are prime. Yes or no, children? So implies that A square is equal to P1, P2, P3 up to Pn into P1, P2, P3 dot Pn. Yes or no, children? If A is P1, P2, P3 up to Pn, A square is equal to P1, P2, P3 up to Pn. Yes or no? Where these primes not necessarily distinct. These primes are not necessarily distinct. Distinct means different. Yes or no, children? What are P1? Why do you say P1, P2, P3? They are distinct. This prime factorization need not be distinct. Getting confused. Come to 8. What are factors of 8? 2 into 4. Again prime factors of 4. 2 into 4. Then again we factorize 4. 2 into 2 into 2. Yes or no? What are factors of 8? They are not distinct. They are same. Distinct means different. They can be same also. Yes or no, children? So what we said? Let the prime factorization of A be as follows. Where A is equal to P1, P2, P3 up to Pn, where P1, P2, P3 are prime numbers. Then A square will be what, children? P1, P2, P3 up to Pn into P1, P2, P3 up to Pn, and these primes are not necessarily distinct. Yes or no, children? Yes. Then I'll arrange this. I need the space. So now come to the theorem. From the fundamental theorem of arithmetic, fundamental theorem of arithmetic, the prime factorization, the prime factorization is unique. Yes or no, children? Prime factorization is unique. Unique means what? It's only one. What does it imply? Implies that P is a prime factor. P is a prime factor of A is equal to P1, P2, P3 up to Pn. Yes or no, children? See, again and again we are studying same thing. Yes or no? So again by using, again write it in words, only you have to write it in sentences. So I'll arrange this, children. Yeah. So I'll arrange this. Top one. What do we say now? By the Uniqueness of fundamental theorem of arithmetic by uniqueness of by the uniqueness of fundamental theorem of arithmetic, P is one of the factors. P is one of the factors of A. Yes or no, children? That is implies that is A is equal to P1, P2, P3. I told you again and again we are writing same thing. Only logic implies that P is one of the factors. P is one of the factors. What does it? Yes or no? P is one of the factors. Therefore, P divides A as well as P divides A implies that P divides A square or P divides A square, P divides A. Yes or no, children? Yes. So this is about proving out P is a factor of A. P is a factor of A or P divides A as well as P divides A square. So now we'll prove that root 2 is irrational. This question will come, children. Prove that root 2 is irrational. Prove that root 2 is irrational, or root 5 is irrational, or 5 plus root 3 is irrational. See, whatever be the number, procedure is same. So our next topic and last topic is proving that root 2, root 3 and root 5 is irrational. Next topic and last topic. Children, our last topic I told you. See, prove that root is irrational. Prove that root 3 is irrational. Prove that root 5 is irrational. More than 2, 3, 5 they will not give. Root 7, root 8, root 11 and all. Prove that root 2 is irrational, or root 3 or root 5 combination of root 2 plus 5. And that's all. Look at the procedure. Procedure will be said. Now, what information is given, children? Nothing. Prove that root 3 is irrational. We have to contradict the statement. Start from contradiction. What is contradiction of irrational? That is rational. Because no information is given. Let root 2 be rational. Let root 2 be rational. What does it imply? Now, if root 2 is rational, then root 2 can be written as P by Q. Yes or no, children? What we discussed in previous topic, where P and Q are co-prime. You have to write this, children, and remember co-prime. We said we studied what are co-primes. Yes or no? And we know what are co-primes. So write this as co-primes. This is the basis for the proving this. We said very important. P and Q are co-primes. Means what? P and Q should not have HCF greater than 1. What the HCF of two numbers? That's 1, not more than 1. For example, 2 by 3 I said, or 4 by 5. 4 is a composite number, but when it comes with a prime number, HCF will be 1. You cannot divide. Yes or no? Yeah. So, you cannot further simplify these numbers. Now, suppose we arrive at this number 4 by 8, 3 by 6. What happens, children? Then our assumption is wrong. Isn't it? Means what? They have a common factor 3. They have a common factor 4. Then they get reduced to simplest form. Yes or no? Yeah. Let root 2 is equal to P by Q, where P and Q are co-primes. And Q is not equal to 0, obviously. Now, what is next step, children? Squaring both sides. squaring both sides. What do you get? Squaring both sides. What will get? Squaring both sides. So root 2 square 2 is equal to p square by q square. What does it imply, children? P square is equal to 2q square. Just now we proved. Yes or no? So what does it imply? 2 divide p square. What does it imply? 2 divide p. So similarly q divides q square divides p square implies that q divides p. What does it imply? Now 2 has 2 factors. What are they? 2 and 2. Yes or no, children? Yes. Now we'll call it as equation number 1. Yes or no? Yeah. Now what are we do, children? Let us this top one. Let us this top 2 lines. So p square is equal to 2q square. Understood? Let p is equal to 2c. What does it imply? We want p square value, children. Yes or no? 4c square. Yes or no? Yes. So what do we say now? What is the value of p square? P square substitute here. 2q square is equal to 4c square. Yes or no? 2 1s are 2 2s are. So what do we get, children? Keep this equation as it is and continue here. What do we get from here? Or I'll do one thing. P square is equal to we require this equation. P square is equal to 2q square. What is that? Equation number 1. I will retain that. P square is equal to 2q square. Yeah. Now, what is q square, children? Q square is equal to 2c square. So, what does it imply? 2 divides q square implies that 2 divides q. Yes or no? What we said here? What is that? 2 divides. Therefore, 2 divides both p and q. Yes or no? Here we said 2 divides q square, 2 divides q. Here we said 2 divides p square, that 2 divides p. Yes or no? Then this contradicts our assumption. Let p is equal to, let what we said here, let root is equal to p by q, where both p and q are co-prime. That is the HCF is 1. Yes or no? So what we said here, 2 divides both p and q. But in the beginning what we said, let us assume that root is equal to p by q, where both p and q are co-prime. This contradicts our statement that P and Q are co-prime. Yes or no? This because 2 is the common factor of both P and Q. This contradicts our statement that P and Q are co-prime. Therefore, I'll erase this. Over, children. Almost over. One more line. So, implies that our assumption that root 2 is rational is wrong. Rational is wrong. Implies that root 2 is irrational. Hence prove. That's all, children. That's all. What we started with, prove that root is irrational. We proved that root is irrational. How did we prove? First we said, what is that? Contradiction. Contradiction means what? Opposite of what is given. Because no information is given here. Let root 2 be rational. Then root 2 can be written in the form of P by Q, where P and Q both are co-primes, means their HCF is 1. Then what we said, root is equal to P by Q, squaring both sides we get 2 is equal to P square by Q square. Then we cross multiply. P square is equal to 2Q square. What does it imply? 2 divides P square, 2 divides P. Q divides Q square divides P square, Q also divides P square. P. So that part you can neglect it. Q divides P. What we said here? 2 divides P square, 2 divides P. Equation number 1. Yes or no? Then what we took? Let P is equal to 2C. Then P square will be 2C square. That is 4C square. What is P square? 2Q square. 2Q square is equal to 4C square. Then what we get? Q square. Q square is equal to 2C square. What we said? 2 divides Q. Previously we said 2 divides P. Here we said 2 divides Q. So 2 divides both P and Q. This contradicts our statement that P and Q are co-primes. Why? They don't have HCF 1 as per our assumption. They have HCF as 2. What does that mean? Our assumption that root 2 is rational is wrong. Because we assume that root P and Q are co-primes. No, they should not have HCF more than 1. We contradicted our own statement. So our statement that our assumption that root 2 is rational is wrong means that what? He is right or she is right, that root 2 is irrational, hence proved. So this is 3 marks, children. Root 2 or root 3 plus 5, 1 by root 2, whatever it is, same procedure. Please pause this video, practice and practice with other numbers. If you have any doubt, put it in comment box. Please put it in your comment box, whatever doubt you have. Understood, children? And subscribe my channel. All notification, whichever videos I do in future, you will get it automatically, which will help you to score out of 4. Not only in math, I will do science videos also. Physics, chemistry, biology. End of the topic, children. Thank you. Do well. Goodbye.